Okay, today we're going to be starting chapter 11 and working on radicals, and today we'll be focusing on simplifying radicals. So to get into this, I want you to try a couple example problems before we start in the meat. But if you try this, I want you to find square root of 4 times square root of 9. Okay, and you need to be following the proper order of operations. So I need to be seeing here that you're doing square root of 4, which is 2, times square root of 9, which is 3, and then go ahead and multiply that, okay? I'm going to give you 4 problems to do. I want you to make sure you're doing proper order of operations and do them all without me, and then come back and check. So now I want you to find square root of 4 times 9. So again, proper order of operations. This time you need to do 4 times 9 first, so square root of 36, which equals 6. Okay, next time, square root of 16 times square root of 4. So here you want to do square root of 16 is 4. Square root of 4 is 2. 4 times 2 equals 8. Okay, square root of 16 times 4. So this time 16 times 4 first is 64. Square root of 64, it is 8. I want you to make a conjecture. So what do you think might always be the case? We've just seen a couple examples. Notice this equaled 6, and this 2 equaled 6. This was 8. This also equaled 8. If you came up with something sort of like this multiplication rule, that will be great. So I would highly recommend writing this down. This is called the multiplication property of square roots. For every non-negative number a and b, the square root of a times b equals the square root of a times the square root of b. Okay? We're going to be using this property a lot to do something called simplifying radicals. When we simplify radicals, a lot of times we're going to have them kind of in this form first, and we're going to break it up into 2 problems. So, here's a rule we're going to be focusing on when we start simplifying radicals. For a radical to be simplified, the radicand, that's just the number under the square root symbol, or the expression under the square root symbol, that cannot have any perfect square factors other than 1. Okay, so you don't want any number to go into that unless it's a perfect, or that is a perfect square. Okay, that will not be considered simplified form. Just like if I had a fraction that was like, hey, this is 6 over 10, you would say, hey, that's not simplified because 6 and 10 have a common factor, so we need to write that as 3/5. If we have a radical that has a perfect square that goes into the square root, we say it's not simplified. So it's really, really helpful if you know your perfect squares. Obviously 1, but that doesn't do as much good. 4, 9, 16, 25, and I hope you can see you're just generating these by 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. So I do 36, 49, 64, 81, 100. If you know by heart like up to 144 or something, that will probably be a good enough start for now. But you need to recognize if any of these numbers go into the radicand. So I'm going to start out with some simple examples and then we'll get a little bit harder. So starting out, if I ask you to simplify square root of 50, okay, here's the process. You look at 50, which is the number underneath the radical, the radicand, and you say, is there any perfect square that goes into 50? And I hope you can automatically recognize, yes, 25 goes into 50. So we could rewrite 50 as 25 times 2. Okay? So we would know that the square root of 50 is the same thing as the square root of 25 times 2. Based on the multiplication property of square roots, we can say that equals the same thing as the square root of 25 times the square root of 2. Okay? I like this because I know what the square root of 25 is. I didn't know exactly what the square root of 50 is, but I know exactly what the square root of 25 is. That's 5. I don't know what the square root of 2 is exactly. I'm going to leave that the square root of 2. And to see if I'm done, I just have to say, does 2 have any perfect square factors that go into it other than 1? And it does not. So I think I'm done. 5 square root 2 is how we say the square root of 50 is simplified. And I definitely think it's very worthwhile to get into the habit of confirming on your calculator that these at least equal the same thing. So if I would be on your calculator, and trying to double check my work, I'd say square root of 50. Okay, and I'd find a decimal approximation for that, about 7.07. And then I would do 5 square root 2, okay, which is what I thought it was. And you're going to notice that it's still 7.07. Okay, so these two numbers, they're equivalent. They equal the same thing, but 5 square root 2 is considered simplified. Okay, so let's have you try one. See if you can do this. Simplify square root 72. Okay, I'm going to show you a couple ways that you could do this problem, but you try it on your own first. Okay, this is what I would probably do. I would notice, okay, what's a perfect square that goes into 72? I just automatically noticed 36. So, this is square root of 36 times 2. 36 times 2 is 72. So, I know this must be square root of 36 times square root of 2. Again, I know that 36 is a perfect square, it's 6 squared, so square root of 36 is 6 times the square root of 2. Okay, I think that's my final answer. Again, I would probably go to my calculator and plug in those and see if they match, but I want to show you one other way that you might have done this. You may not have noticed that 36 went into 72, and you might have started with something smaller. You might have said, well, square root of 72 is 9 times 8. So instead of 36, I'm going to do this. Square root of 9 times 8. So I'm going to do square root of 9 times square root of 8. And I know square root of 9 is 3. I don't know square root of 8. It's root 8. Okay, well, these do equal the same thing. This is not simplified. Okay? The reason being is because 8 still has a perfect square that goes into it. So you may notice that 4 goes into 8. So I'm going to have to keep going in this case. If I didn't pick the biggest perfect square right away, I'm going to have to keep going. So square root of 8, that's square root of 4 times square root of 2. And again, I know what the square root of 4 is. So now I have 3 times square root of 4 is 2 times square root 2. And I know 3 times 2 is 6. So I have 6 square root 2. Either way, I'm getting the same answer. If you have 3 root 8, it's going to be equivalent, but it's not going to be simplified. Okay? Let's look at a couple that have some variables in them. I'll make it a little trickier. All right, if I just asked you to simplify square root of x to the 6th, you would be thinking, I wonder what times itself equals x to the 6th. And I hope you would notice, hey, well, x to the 3rd times x to the 3rd equals x to the 6th. Therefore, the square root of x to the 6th must be x to the 3rd. Okay? I hope you can automatically see that. But if we don't have that being a perfect square in there, so here we have square root of y to the 9th. If I tried something like, well, y to the 3rd times y to the 3rd, that equals y to the 6th, not y to the 9th. So we're going to have to do a little bit more work here. When we're looking at y to the 9th, we need to see the biggest perfect square that goes into it. Okay? Now I hope that you know that y to the 9th, that would be the same thing as y to the 8th times y. Okay? And the good thing about that is y to the 8th is a perfect square. Okay, so if I look here, I could do, oops, I didn't break it up, but I could do square root of y to the 8th times square root of y. So square root of y to the 8th times square root of y. And I know what square root of y to the 8th is, because y to the 4th times y to the 4th equals y to the 8th. Okay? So square root of y to the 8th is y to the 4th. Square root of y, I don't know what that is. It's not a perfect square. It has no perfect square factors. I'm done here. I think you should be noticing some relationships between an odd power and an even power. Okay? So if I asked you to simplify square root of y to the 9th, you would have y to the 4th times square root y. If you were to simplify square root of x to the 6th, you would just have x to the 3rd. Okay, now let's put some of this together. So here, I'm going to simplify square root 243. Try that one on your own because it's just a number. Okay, I'm looking for perfect squares that go in. I notice automatically it's 81 times 3. Okay, so square root of 81 times square root of 3. Square root of 81 is 9. Square root of 3, unknown. There's no perfect square factors that go into 3 other than 1. So I'm done. Okay, and of course, great idea if I would check that on my calculator. So I'm going to try square root of 243, and then confirm if that really is the same thing as 9 times square root of 3. So 9 root 3. And they're both about 15.588. Yep, they're equivalent. So that's good. I probably didn't mess up because 3 doesn't have any square root factors, perfect square factors. Okay, now let's put it together. Simplify the square root of 28x to the 7th. So this time I might have a lot of breaking up to do. I'm going to look for perfect squares that go into 28. I notice 4 does. So I'm going to call this the square root of 4 times the square root of 7. I'm also going to be looking for perfect squares that go into x to the 7th. And the highest one is x to the 6th. So I'm going to call that square root of x to the 6th times square root of x. Okay, and then I'm going to start simplifying everything I can. Okay, so square root of 4 equals 2. Square root of 7 unknown, so just keep it square root of 7. Square root of x to the 6th, that equals x to the 3rd. Square root of x, unknown. Okay, but this doesn't look very pretty. I like to simplify it. And remember, when you're multiplying, order doesn't matter. So I'm going to put everything that's not in a square root together. So I'm going to put 2x cubed all at the front times square root of 7 times square root of x. And hopefully you recall from the beginning. So square root of a times square root of b just equals the square root of ab. So we could call that just the square root of 7x. My final simplified form would be 2x cubed times square root of 7x. Okay, let's look at a couple more like this that I want you to kind of try on your own. Okay, so simplify root 12 times root 32. Many options here. Okay, you could actually multiply them out first, or you could try simplifying first. I'm going to try simplifying first because I think that will be easier in this case. So this is 4 times 3, so root 4 times root 3. And 4 also goes into 32, but I'm going to pick 16 because it's bigger and I know that will be less work eventually. Okay, so I'm going to do everything I can. Square root of 4 is 2 times root 3. Square root of 16 is 4, and then just times root 2. Again, order them so it's nice and convenient. 2 times 4 is 8. Root 3 times root 2, I could rewrite that as root 6. So we have 8 times root 6. And 6 does not have any perfect squares that go into it, so I'm done. Okay. Highly worth checking on your calculator, though I'm not going to do that this time. Okay. And then this will be our last one for today. 7 root 5x times 3 root 8x. So again, I'm probably going to start by grouping the ones like 7 times 3 is 21. Root 5x times root 8x. So remember, I can do this, root 5x times 8x like that, and that's root 40x squared. But this time I'm not done because 40 has perfect square factors and x squared does as well, so I need to keep going. So square root of 40, that's square root of 4 times square root of 10 times square root of x squared here. Okay, I know square root of 4 is 2. I know square root of x squared is x. I don't know what square root of 10 is. I'm going to leave that square root of 10. And I'm not going to forget about my 21. So I've got 21 times 2x times root 10. That's got 42x times root 10. 10 doesn't have any perfect squares that go into it other than 1. So I'm done. All right, so you're going to practice the simplifying, and tomorrow we're going to add another step to it.